Hey, what's going on, everybody? It's your boy Algebra coming to you live and direct from the studio. Last video of the semester because your boy is coming back to class on Monday, leaving my little homeboy Av here with his mama by himself all day. You know, it's, they're gonna get into. But for right now, uh, we're gonna do some elimination. Yesterday was your first shot at it. Did not give you all the possibilities, all the details on that first video, but today I'm going to go into a full in-depth exploration of how to use elimination to your benefit. First one's got to be a story problem. From there, we'll just start making them up as we go. Let's talk about my man, Old McDonald. So, following Thanksgiving, a whole settlement of runaway turkeys and pigs was found outside of Old McDonald's farm. Like they knew the holiday was coming up, so they just got out of there, because of what the holiday is. It is what it is. So there's 50 animals, totaling about 144 legs. And I want to know how many turkeys ran away. So what you need to uncover in this situation is again, what are the variables and what are your equations? Here we go. There are 50 animals. That's going to be your first sentence. Your first numerical statement is that the turkeys plus the pigs has to be 50. You remember a video a couple days ago, I called this the counts. The second equation talks about their legs, and that was the value equation. The value equation always talks about attaching a particular value to the variables that you already created. Turkeys have 2 legs, pigs have 4. The total is 144. So now you have 2 variables. You got them set up. Now you need to know what to do with them. Yesterday we started to say that substitution was effective but not efficient. We want to maximize the amount of problems that we can do in a short span of time, and we're going to do that by using elimination. Elimination says if you can match up 2 variables, bless you, Av. If you can match up 2 variables, you'll be able to go ahead and literally eliminate it from the entire problem. I'm suggesting that we either make this T have a 2 or this P have a 4. Either way is going to help me get rid of one of those variables. And I only need to get rid of one at a time. I'm going to take the first equation and multiply the entire thing times 2. Bless you, Av. Man, Averett is over here just coughing and stuff. That's okay. Negative 2t minus 2p equals negative 100. And so your question for me should be, well, why did you use a negative 2 instead of a positive 2? Well, if I use a negative 2, that means when I add, they're going to cancel out. If I use a positive 2, I would have to do subtraction, and subtraction gets a little bit messy sometimes because of all those negatives. From this point on, all you need to do is just add. The t's are going to cancel out. The negative 2p and the positive 4p is going to make 2p. And the negative 100 with the positive 144 is just 44. So p equals 22. That's a good piece of information to know. Now you know how many pigs were on this runaway settlement of Old McDonald's animals. We need to do the same thing and figure out what the t's are. Plugging it in. T plus p equals 50. That means t plus 22 equals 50. And then finally, you end up with an answer that says there's 28 turkeys. So this entire story problem we're able to do using elimination once we had it set up. And the elimination process said if you have your variables stacked on top of each other, it will make it easier for you to see what needs to be multiplied onto one of those equations to make it match and disappear. I'll give you another example. Here we go. The example is 5x plus 3y equals 21, and 2x minus 6y equals 3. So between these two equations, what you really need to understand is what is the easiest variable to eliminate. When I look at this, 5 and 2, those don't really work well together. It's not a good choice. But 3 and 6 do. I know that if I multiply the top equation by 2, then this will help me just get rid of the entire y variable. So that's going to be my process. That's going to be what I want to do. If I use the 2 to help me, I can just have a single variable left over. Big brackets with a 2. Whenever you use big brackets, you always have to multiply every single thing inside of that equation. Therefore, this becomes 10x plus 6y equals 42. Everything had to change. The bottom one doesn't. Add your two equations together. Remember, the whole point was that that should just cancel out in the middle. So you end up with 12x equals 45. And your x value is 45 over 12, which can be reduced into 15 over 4. Of course, you're not finished at this point, but the beginning of the problem is what's the most important. Being able to take this and plug it in is something that we've been doing for a long time. You would take your 2 and replace the x with your 15 over 4 that you just solved and got. Distribute. And since you hate fractions, might as well get rid of them. Move everything to the same side. And finally, your answer comes out to be pretty nice in the grand scheme of things. Y is 3/4. So on the next question, I'm going to change it up just a little bit to force you to think half a step farther. And the next question is 2x plus 4y equals 18. Coupled with 3x minus 5y equals negative 17. The long pause is for you to think about the fact that neither one of these is a really good setup for you. 4 and 5 don't really work well together, but neither do 2 and 3. So for this situation, you've got to make a decision. And that decision is, which one do you want to get rid of and how? I have an answer for you. I want to get rid of the y. And you can say, why not get rid of the x's? They're smaller numbers. They'll be easier. But if I get rid of the y's, I don't have to worry about any extra negatives. Remember, two things need to come into play. The first thing that you're looking for is, do the numbers match? Are there coefficients that are matching? Second thing that you want to look for is, do you have a positive negative relationship? In order, if you have coefficients that match, that's your decision. You want to get rid of that variable. If you have a positive negative relationship, but they didn't match, that's the one that you want to use. If neither one of those things is happening, then you can just get rid of it. Yeah, you can just go ahead and choose whatever you want. So at this particular juncture, I'm going to choose to get rid of the y variable and leave the x's where they are. But how do I get rid of the y variable? Sure, I have a positive negative relationship, but what do I do with it? I need the coefficients to match. So how do I match the coefficients? Well, this time, instead of just multiplying one equation, I am going to multiply both. I'm going to multiply the top one by a 5, the bottom one by a 4. And notice what ends up happening, even though it's multiplying two different values onto two different equations, you're creating a situation where they can cancel each other out again, which is exactly what we wanted to have happen in the beginning of the problem. Now that you're here, notice your y's are gone, so you end up with a 22x equals a 22, and x has to be 1. Take your answer and plug it back in, and now you have 4 different options for plugging it back in. You can use either one of those two blue equations, or you can go back to the beginning, which is what I'm going to do. 2 times 1 plus 4 times y equals 18, which makes 4y equal to 16, and y is just 4. So this concludes part 1 of the video. When I come back, I'm going to give you some step-by-step directions and a couple more examples. Peace.